Good morning, everyone. Assalamualaikum warahmatullahi wabarakatuh. It is an honor to be presenter in this international conference on energy storage, technology, and application, ICESTA 2022. In here, I want to present about my research for the title ZnONR or ZnONR, Microstructure and Modification, and their potential for high stability performance of activated carbon manganese 2 oxide supercapacitor. For the first author, Professor Markus Diantoro, and me, Ishmah Luthfiyah, and Mr. Wisodo, and Mr. Joko Utomo. For the last author is Associate Professor Worawat Meevasana from SUT Thailand. For the next slide, in here I want to present about the background of the ZnONR and how if I want to composite the ZnONR with the activated carbon and Mn2O3, and how about the impact for the ZnONR for the performance. In the background, government plans sustainable development of the electrical technology sector from renewable energy storage in Indonesia up to 85% by 2040. So this effort will require electrical energy storage devices with greater performance. And about this plan from the Indonesia, we need a big or the good materials to make the electrical energy storage device. And in here, I make the research about the modification additional of ZnONR. In here, if you want to make the electrical energy, you must optimization by the active materials and the conductive materials. For the active material, we use the activated carbon and Mn2O3. For the conductive material, we can combine by carbon black and ZnONR. For the active material, we need the performance is like the specific capacitance is more high and the low toxicity, because in here for the materials like the battery is having very high toxicity. And for the two, we need the material is low cost and abundant in nature. But the weakness from the active materials is having low electrical conductivity, accessibility electrolyte, and low ion diffusion. So from this problem, we must make the composite material Mn2O3 and addition by activated carbon and composite again with the carbon black and composite again with the ZnONR is needed to improve the performance of the supercapacitor. So the modification of additional ZnONR is having in the research from the Mustika study et al. From this the research, we can know that the nanostructure modification has different physical properties. The structure of the nanorods can evac a material to improve storage performance because the surface area more higher than nanoparticle. And then for the other research from Zongzhan et al. At the 2016, the specific capacitance if you use with the ZnONR increase multiple too with the addition of the ZnONR. For the example, if you just using the MnO2 nanowire, you just get the performance is 120 farad per gram. But if you composite with ZnONR, you can get more higher, that is until 261 farad per gram. So based from the that's theoretical modification, ZnONR and the Mn2O3 or MZnONR in here, I make the title for my sample. So you must know that compound about the supercapacitor, you must optimum by the electrode, electrolyte, and separator you use. And then why in here I make the modification electrode, because if you want to make more higher performance, you must optimize by the electrode materials. So what is the impact? The impact is you can get an effective way to improve the energy density and power density of energy storage device. And that is the optimum for to achieve low cost production will also be environmentally friendly. And that is the key, or the key important to get the components determining the capacity performance at the electrode material of the supercapacitor. And in here, I make the carbon black because the carbon black is having good in conductive hinge, and that is very good to know how to the electron is can more stable for the supercapacitor. And the next, in here, I want to present about experimental method I use. For the first, you must prepare the aluminum or activated carbon black. For the binder is PVDF, and for the solvent is NMP. And in here, I make the electrolyte is 1 molar E4 NBF4. And for the device, I use the spin hood with the depth specification. For the digital maze, for the laser, the maze, and then I use the hot plate, I use the press for the coin cell, and I use the oven. In here, I make the experimental method for the nanoparticles, ZnONR. So in here, for the first, I must to make the material from the zinc acetate hydrate and addition by 20 milliliter ethanol. And after this, I must do addition again with MEA. After this, I must do waiting at the room temperature, but it is still nanoparticle. So how do I make the nanoroach? I need to immerse in the solution for the 5 hours. After I get it, I must to use the furnace. After I get the film of ZnONR, I must to deposit again with the activated carbon, Mn2O3, and carbon black. This is after I get the solvent of activated carbon, carbon black, and Mn2O3, I deposit in the aluminum foil. After this, I must do fabrication my supercapacitor using the coin cells. For the first, you must be using coin cell kits, spiral or electrolyte arrange the electrodes. After this, you need to injection with the organic electrolyte for the 1 molar of ED4 in A4. After this, you need the fabrication process should be handled with care because the electrolyte is very toxic. And the first is the coin cell. After you get the coin cell, you must characterize. And for the next, this is my result and discussion. For the first, I get the performance from the X-ray detection. That is, I use the variated by the speed speed of the spin coating. For the first of speed is 1,500 rpm, and the 2,500 rpm, and the 3,000 rpm. And here you can see that for my one sample is MZNONR1, that is having the speed of the spin coating is 1,500 rpm. From my sample at the 1,500 rpm, you can see that the intensity for the material is more higher than other. You can see it that's in the files 0.0002 and 001. And here we can get the conclusion that addition of the ZnONR of the Mn2O3 activated carbon black materials in increasing the intensity diffraction pattern in the ZnONR piece called the 011. And from the result of the refinement, you can see that parameter of TC, the higher rate of the spin coating parameter, the crystal width and polymer will get more lower. After this, the result and discussion. This is I measure about the crystal size. From the crystal size, we can get a full weight height measure. We can get a 0.187. So in this sample, MZ and Onanuro has highest, it's more get highest the crystal size than the MZ and Onanuro 2,500 and 3,000. And then this is the, if you want to see the about how to confirm the modification, it's good. So we can characterize by the scanning electron microscopy. We can get the, if just that another road, we get the performance like this. The road is really real having enriched film. But if we addition with activated carbon and N2O3 and carbon black, we can see in this. And for the thickness, we can see in that MZnONR at the 1,500 rpm, we get a thickness is 43.76 micrometer. And if you use the more higher the speed of the spin coating, we can get more higher the thickness because having something problem at the laboratory. But for the result in this session, we can see that MZnONR for the 1,000 for 1,500, we get the performance. It's more the stability. Because what? Because the high compound of the Zn in the lower speed of spin coating having effect cycle stability more stable with identical rectangular EDLC course. This is shown by the MZnONR for the 1,500 sample with the highest Zn content until 10.2%. At low Zn content with a faster spin coating rate, the core form is unstable. That is, you can see that from my picture. And then. So for the result, the supercapacitor symmetric of the MZnONR 1,500, we can know the specification for the first. The specific capacitance is 7.05, and the energy density we can get the 5 for 14.09 watt hour per gram, and the crystal size is until 110, and the crystallinity is until 56, and the compound of the Zn is more higher than other, that is 10.2, and the thickness is more lower than other, that is 43.76, and the porosity we can get the 69%. And we can see that the result is more stable than other. You can see this if I make the variation of the skin rate, my materials of the MZnONR it get more higher and more stable than other. And then for the final result and discussion, if you make the from the thin film ZnONR, you just get the performance is 0.00867 farad per gram. But if you addition with the activated carbon and N2O3 and the carbon black, you can get more higher, and that can increase more multiple by 800 more than symmetric supercapacitor. That is, we can get more, that's 7.05 farad per gram. So the conclusion, the performance of ZnONR is can get the increase until 800 multiple more than the symmetric of the ZnONR. And then for the, if you want to know the porosity of the, if you just using the porosity ZnONR, you just get the 56%. But if you're using with the addition activated carbon, Mn2O3 and carbon black, you can get more higher the porosity until 69%. So the conclusion and acknowledgement. For the conclusion, in summary, we found that the higher the spin coating of the speed, the less of the material capable of the depositing on the substrate surface. Hence, the microstructure as well as the electrochemical performance also reduce. The addition of the Mn2O3 activated carbon-carbon black to ZnONR aluminum increase the specific capacitance and energy density of the symmetric supercapacitor Mn2O3, ZnO nanorods, and activated carbon-carbon black with the with the substrate is aluminum foil for all the different morphological variants. And the last, the specific capacitance and energy density sample with the speed of the spin coating until 1500 atm reach until 800 multiple from the 0.0086 farad per gram and 0.430 watt hour per gram to 7.04 farad per gram and the 14.09 watt hour per gram. And thank you very much for the acknowledgement. Our sincere thanks are addressed to the DRTM, Ministry of the Research, Technology, and Higher Education, respectively, Republic of Indonesia, for the financial support under the Basic Research Scheme for Markus Diantoro or Materials Development Production. Thank you very much. And if you have any question, you just can ask to me. Wassalamualaikum warahmatullahi wabarakatuh.